My name is Ege Özbülbül and this is my Physics 102 lab project video. My project is to find the dielectric constant values of three different dielectric materials like styrofoam, rubber and dry wood. In order to conduct my experience, first I made two parallel plates by using cardboard and aluminum foil. I shaped them in the dimensions of 12 times 10 and make two parallel capacitors. First of all, I measured the capacitance value of these parallel capacitors without a dielectric material between them. In real, there is air between them. However, since air has approximately one dielectric constant value, I neglected the capacitance that is being produced by the air. Then I put dry wood, rubber and styrofoam respectively between the parallel plates and removing the previous dielectric material that I put before in order to measure them one by one. In the final part of the project, I put them next to each other and making a series connecting capacitor. Since series connecting capacitors have a well-defined formula, I use that formula in order to find the equivalent capacitance of these series connected capacitors, and then I measured the capacitance of this series connected capacitor, and I compared the two of them. Then I found that there is a error of 150%. And this was my experiment. Here I'm measuring the capacitance value of a capacitor without a dielectric constant, and I have found the value 0.019. Now I have put dry wood between the parallel plates of the capacitor and I have found the capacitance value as 0.34 and the dielectric constant value that I found is 1.79. Then I put styrofoam between the parallel plates of the capacitor and found the capacitance value as 0.21 and find the dielectric constant value as 1.12. Then, after styrofoam, I put rubber between the parallel plates of the capacitor and found the capacitance value as 0.027 and find the dielectric constant value as 1.42. Finally, I put every dielectric material, styrofoam, rubber, and dry wood next to each other, making a series connected capacitor, and I have found the equivalent capacitance value as 0.020 farads. However, if we use the formula of the equivalent capacitance of series connected capacitors, the value should be 0.008. Thus, I have an error of 150%. Again, I have found the dielectric value of rubber as 1.42. However, according to my research, the The electric value of rubber should be 2.5, which gives us an error of 43.2%. Then I found the electric value of styrofoam as 1.12. However, it should have been 2.55, and this gives us an error of 56.1%. And finally, I found the electric value of dry wood as 1.79. However, again, it should have been 1.22, which gives us an error of 21.8%. Approximately, I had 40% error in each dielectric value that I found, and this may be due to several things. First of all is that I may have misread the values in the multimeter or in the ruler when I used in order to cut my parallel plate from cardboard. The second one is that I may have not shaped the cardboard perfectly. For example, I may not have cut the cardboard as 12 times 10, but for example 12.1 times 0.9 centimeters. The third one is I may have placed the dielectric materials with a gap between the parallel plates and not placing them exactly next to the parallel plates, which will affect the capacitance value and therefore affect the dielectric value that I found, since the gaps that may have occurred between the parallel plates may have created another capacitor that is series connected to this capacitor with the dielectric constant of air 1. The fourth one is that the materials that I have used may not be 100% pure. They may have had another substances in them. So this gives us a different dielectric value and a different capacitance value. The fifth one is if our dielectric materials are not 100% and has a substance that is a conductor, all charges cannot be completely stored, and some of them can pass between the parallel plates, which will decrease our capacitance value. Like if our dry wood has, for example, 1% metal in it, our capacitance value would have decreased. The sixth one is the multimeter may not be fully and accurately calibrated, which gives us a different value. The seventh one is there may have a miscalculation in my equations, in my formulas, which I don't think they are, but it's a possibility. The final one is the environment. For example, if there was an airflow in the part of the lab that I had conducting my experience, the parallel plates may have like moved slightly or like oscillated, which would change the distance between the parallel plates and the dielectric material, and again that will give us a different value, and that would again cause an error.